All right, so this is the additional part of our live session that was on October 14th. We're looking at the Chapter 5 clickers and activities, and we're starting in here on slide 41, talking about distinguishing between ionic and covalent compounds. And again, if I drop my my image of the periodic table in here, which I thought I had. Let's see here. I'll insert a... Okay, that's very weird. I'll go and find my periodic table, or a periodic table to put here. All right, so here is our periodic table over here. So basically, remembering that hydrogen is a nonmetal, maybe think of it sitting over on top of fluorine there. A covalent compound is going to be both of the things coming from this, the nonmetals, nonmetal, nonmetal. And this line right here, the staircase line, is this thing that distinguishes between nonmetals on this side and metals going back that way. And then ionic compounds are going to be nonmetal with metal, nonmetal, or we could have polyatomic ions plus nonmetals, or metals plus polyatomic ions, or even polyatomic ions combining together. So all of those tend to be ionic, which achieve their octet rule by transferring electrons, not sharing them like the covalents do. And of course, you got to recognize which one's which because you're dealing with naming them differently. So looking at these guys, you can see the results here they have for whether these are ionic or covalent, and then how they're named. So a few examples there for you to review. Again, I really strongly recommend the Naming Compounds handout, which I will post the key to in a few days. So looking at these, we have to identify one that is not ionic. So what I'm looking for here is I'm looking for something that only has nonmetals in it. And that's going to be our PBr3, which is phosphorus tribromide would be the name of that. One way we can experimentally tell if something is ionic, and I'm not sure what problem with our image is here. I think this is simply says NaCl in water, is I think what the caption's supposed to say there, and it looks like it just overheated. But what we have here is a battery. This is our battery here, and a light bulb. And the circuit, the electrical circuit, has to go through the solution. And if you have pure water, it turns out that light bulb won't light up. Pure water actually doesn't conduct electricity, but it has to be really, really pure water. So pure water, you know, no light. But it has to be really pure. And in fact, the way we normally measure what pure water is by essentially conducting this experiment and telling how much resistance there is to the flow of the electrons through the water. And if there's a lot of resistance, and resistance is an electrical term, then that's considered to be very pure water. NaCl in water is going to break up into sodium ions and chloride ions in water, so that is going to conduct the electricity and the light will light up. And the more dissolved ions there are, the stronger the light will be. So what happens again is you're in a solution of an ionic compound. Typically, most ionic compounds dissolve, and when they dissolve, they dissociate, which is that the ions come apart. So another big skill, I talked before about the importance of knowing your polyatomic ions and knowing the type of monoatomic ions that form. One of the skills is knowing what's going to happen in solution. So, for example, if you were asked, what's in a solution of baking soda. So if I take solid baking soda, which is sodium bicarbonate or sodium hydrogen carbonate, and I add that to water, what does that break up as? And there's lots of possibilities here. You might think that all the atoms break apart, but that's not what happens. What happens is you form the sodium ion and you form the bicarbonate ion. And again, knowing that HCO3 minus is a polyatomic ion is how you know what actually happens when things dissolve in water. So now we're looking for a compound that does not dissociate, and one thing for sure that's not going to dissociate is a nonmetal covalent compound. So if I look through these, I see that CCl4 is our nonmetal compound that isn't going to dissociate in water. That's carbon tetrachloride, that's called. Now, acids are a classification that we apply to compounds that help us, predict some of the reactivity of the compound. Things that are acids tend to act in the same way, and generally what they do is they produce H plus ions when they're dissolved in water. The H plus ions are called hydrogen ions or protons. They're called a proton because a hydrogen has one proton and one electron. If you make the H plus, it's only got one proton. So we'll talk about proton donors. The other thing folks talk about is they also talk about the hydronium ion, which if I take H plus H2O, we get H3O plus. That's called the hydronium ion. And the purists really say, okay, we got to talk about hydronium ions. H plus again is called the hydrogen ion, or sometimes called a proton. So here are some acids now. What we have, this group of 4 that are right here, down through there, these are what we call mineral acids. There's a generic term for that. And they look like this. They look like HX, where H is some nonmetal. The rest of these are some kind of oxo or oxy acid, where you've got H, maybe more than one H, plus a polyatomic ion. Okay, and those acids are named differently. If we're talking about a mineral acid, we say hydro, root of the nonmetal name, ic acid. The oxyacids have a naming system where, you remember we talked about the polyatomic ions and we had the ate and the ite and the hypoite and the per-ate system. Those you change ate to ic acid. So if you add the right number of hydrogens to make them into acids, you get per-ic acid, ic acid, us acid. Remember the us and ic before, and hypo us acid. So to look at an example of that, NO3 minus is nitrate. So if I add 1 hydrogen ions to that, I get HNO3, which is nitric acid. If I have ClO4 minus, that's perchlorate. If I add a hydrogen to that, I'm going to get perchlorous acid. Oh, sorry, perchloric acid. If you come across either perchlorate or perchlorous acid, by the way, run quickly to the nearest phone and call the fire department and let them know you have it. Those things tend to be pretty explosive. But distinguishing that, if I have HCl, that's hydrochloric acid. So that's named differently. We don't use that hydro prefix if we're dealing with any of the ones that have oxygen in them. So there is sort of a system to that. One should probably know the 6 strong acids are are HCl, HBr, HI, hydrochloric, hydrobromic, hydroiodic, HClO4, perchloric acid, HNO3, nitric acid, and H2SO4, which is sulfuric acid. So again, here they call these, the mineral acids, they call them binary acids. So that's basically what we just reviewed above. Here is an image showing how our acid, which would have been a little purple and green molecule, so, little purple and a bigger green, where the purple is the H plus and the green is the X minus, maybe chloride ion. And what they're showing is that the water molecules, and of course the things that are red with is oxygen, and the little grayish white things there are hydrogens, showing how the water molecules associate with the ions from the dissociated acids. So you see up here you've got a bunch of water molecules all pointing their oxygens towards the H plus ion, and then down here you've got a bunch of water molecules pointing their hydrogens towards the green X minus ion, just to give you an example of that. So if BRO minus is bromate, we add one hydrogen to get rid of that negative charge. HBRO3 is bromic acid. And then we're asked here, random kind of question, name the compound Al2CO3 taken 3 times. That's going to be aluminum carbonate. Because the CO3 2- ion is carbonate, and we don't have to tell anyone that aluminum is +3. Which one of these is ionic? That barium chloride is going to be our ionic compound. Feel free, by the way, when we come to these questions, if you want to pause the video and try to answer it before I jump in with the answer. That's probably good practice for you. Compounds that form ions in aqueous solutions are called electrolytes. And of course you've heard of how important electrolytes are to us. So now we're looking for one that's not an electrolyte. That means it's not going to dissolve in water, which means that it's not ionic. It's a covalent nonmetal compound, and it's not an acid. So HCl, even though that's a nonmetal compound, it's an acid, so it dissolves in water. HClO4 is all nonmetals again, but it's an acid. It dissolves in water. So our non-electrolyte is carbon tetrachloride here. And then finally, we're down to some speed drills here. The answers are given for these, so you can try these. Again, feel free to pause the video and try these, or try them on your own looking in the OneNote notebook. I am not going to linger over those as we go through those. Then here you're asked to identify things as either ionic or covalent, and of course you've got to be prepared to deal with either the formula or the name. And again, that's a basic chemical skill to be able to go back and forth between the formula and the name. So again, pause the video, take your time, think about these things, and see if you can classify them as ionic or covalent, and then we'll scroll on down and see those answers in a little bit. Well, I thought we would. Let's, just in case we don't, I'll write them in. This is ionic. This is covalent, diphosphorus pentoxide. Silver sulfide is ionic. Boron trifluoride is covalent. And carbon dioxide is covalent. Okay. So here they've already given the answers for the symbol and charge on these ions, and also on these. Then here's some naming practices. See if you can and rationalize those. And again, more naming, getting the formula from the names in this case. And then, here's our ionic and covalent answers. Okay, so those are going back to that. And I think that this is, the design here is to have this be presented in a very large classroom with students using clickers to enter their answers and see how they did. So here's some more speed drills. And again, I'm not going to linger over these, but let you look at the answers and make sure that you are able to do those. And I think some of those are repeats, so we'll just go on through that. So anyway, so that wraps it for Chapter 5, and I encourage you to practice all the sapling homework, and then move on to Chapter 6 just as soon as we can.